So section 3, we're going to be talking about increasing and decreasing functions. So this is going to be more specific, where we're only going to be looking at graphs for this. So first, let's define increasing, decreasing, and constant functions. So when we talk about a function being increasing, what that means is that the y value is going to increase as the x value increases. So we have y value increases as x value increases. So I'm going to draw an example of a graph that is strictly increasing, that's only increasing on the graph. A function doesn't have to always be increasing. You can have a graph that's only increasing for certain x values, and we're going to take a look at that in some of our examples. Second, we're going to talk about a decreasing function. So that is when the y value decreases as the x value increases. So y value decreases as x value increases. And for the example, I'm again just going to draw a graph that is strictly decreasing. And just like with an increasing function, you can have a graph that only decreases for certain values of x. And again, we'll see that a little bit later. You can also have functions that's increasing and decreasing for different intervals on the same graph, which happens quite often. So the third type we can have is a constant function. And a constant function is just a horizontal line. So it's just a horizontal line. So we saw that back in module 1, so just a horizontal line. And you can have a graph that is constant for an interval, increasing on another, decreasing at another time. So you can actually have a graph that is all three of those for different values of x, or you can have a combination of two of them. You could have just one. So you could have multiple things going on with a graph in regards to increasing, decreasing, and constant. So next we're going to talk about local and absolute maxima and minima. So another way you're going to hear that is just max and min. So when we talk about a local max or min, we're talking about the height of the function. So a local max is when the height of the function is greater than the height anywhere else. And you're going to have multiple local maxes on a graph. So you can have multiple points that are higher than somewhere else. A local min, on the other hand, is when the height of the function is less than the height anywhere else. And similarly, you can have a graph that has multiple local mins, some lower points. An absolute max or min is just that highest point or that lowest point of the graph. And there's only one absolute max or min. So it's the most high or the most low. And you can have a graph that only has maximums or only has minimums. It could have neither. So it doesn't have to have both. So let's go ahead and look at an example. I'm going to go ahead and draw a graph here. Let's look at this graph. So when you're looking for local maxes or local mins, you're looking for turning points. So any part where your graph changes direction. So we have one here, we have one up here, and we have another one all the way down here. So those would signify local maxes or minimums. So any low point is a local min. So right here and right here we have local mins. So this is a local min. So is this. It's a low point. Then our point at the top here would be an example of a local max, because it is a high turning point. When we're talking about absolute mins and absolute maxes, this graph actually has an absolute max, absolute min at this bottom point right here. This would be the absolute min. It is the smallest value you ever reach on the graph. And this one doesn't actually have an absolute max because the arrows keep going in this at the top here. It's going to keep getting larger and larger. So there isn't an actual value where it reaches the highest y value. So there is no absolute max, but there is an absolute min for this graph. So let's look at some examples. Let's find on what interval or intervals our functions are increasing and or decreasing. So when we're looking for intervals, we're going to be using interval notation from Module 1. So let's go ahead and just identify turning points. That way we can start looking for where we're going to have turning points. So if we look here, the graph starts up, then it goes back down, then it goes up again. So anytime we have an arrow going up, it's going to be an increasing interval. So if I start with my increasing, so our graph starts off increasing and it continues to increase until this point here. And that seems to be at roughly -2, it looks like. So I'm increasing up until -2. So that would be from -infinity to -2. I'm also increasing from this point down here all the way back up again there. So that one looks to be like the low point starts at 2 and then continues for infinity. So I have a second interval, so we use union, 2 to infinity. Now we're going to look for decreasing it. So anytime I draw an arrow going down, so it looks like that happens right in the middle here. So between those two values. So my decreasing interval is going to be between those. So between -2 and 2 is when my graph is decreasing. So we look at our second example here. We've got 1, 2, 3 turning points. So we're going to start decreasing, then we're going to increase, then we're going to decrease, and then we're going to increase again. So we're going to have multiple intervals of increasing and decreasing. Let's go ahead and start with our increasing intervals. So we increase in this middle part here. So it looks like we're not directly at -1 or -2. It looks to be in the middle. So we start increasing at -1.5, and we increase up until this top point here, which has an x value of 0. My second interval looks to increase at this bottom point and then continue increasing. And it also is not exactly at 1 or 2, it looks to be in that middle. So it's going to increase from 1.5 to infinity. Now let's look at our decreasing intervals. So our graph starts out decreasing and decreases until that bottom point. So it starts decreasing, so -infinity to -1.5. Then it decreases again at this top point to that x value of 1.5. So it's decreasing again from 0 to 1.5. So when we talk about writing intervals of increasing and decreasing, we're always talking about x values. We're looking for the x values where the interval is between which the interval is increasing or decreasing, not the y value, always the x value. Now let's take a look at identifying local max and min of functions. So when you're identifying a local max or min, you still look for those turning points, but those are the only points that matter for local max and min. So this first graph here, we've got 3 points. We want to identify which are local max and which are local min. So let's start with a local max, so a high point. Well, this point up here looks to be a local max. So when we write a local max, we write the actual point. So that point is at 0, 9. So next we look for local mins. And it looks to be like we have 2 low points. So we'll write both the coordinates. So this first one looks to be at -2, -15. And the second one, it looks to be at 2, -15. And because we're listing points, we just list them and separate them with commas. We don't use unions because we're not talking about an interval here. We're talking about a specific point. Our second graph, there only seems to be one turning point, and it seems to be right here. So since there's only one turning point, we have to determine if it's a local max or a local min. Well, it's a top point, which means it's going to be a local max. And it seems to be occurring at -2, 4. The graph doesn't have to have a local min. It can have only one. It could potentially have neither, but in both of these examples, we had at least one. And sometimes you can have multiple local maxes or local mins on the same graph. Let's go ahead and figure out how to determine the increasing and decreasing intervals from a function. So I've given you the function f of x equals 2x squared minus 3x plus 7. So in order to determine the interval or intervals in which it is increasing or decreasing, we're going to graph it. So I've gone ahead and I've inserted the graph here that we obtained from Desmos. So, and I've already got the necessary points labeled. So we're not always going to have nice x values for interval and decreasing. They can be decimals. And when that happens, we typically like to round to 1 or 2 decimal places, depending on how many decimals it is. So there is only one turning point on this graph, and it is this point at the bottom. So when we look at our graph, it starts out decreasing, then we have our turning point, and then it increases after that. So we're going to have an increasing interval starting from our point at the bottom, so 0.75, and continuing on for infinity. Our decreasing interval, I should say, starts out decreasing, so we're going to start at -infinity, and then it stops decreasing at our low point, which occurs at 0.75. So because that low point was only 2 decimals, I went ahead and just used both of them. If you used 0.8, if you decided to round, it would have been fine as well. Let's go ahead and take a look at one last example of identifying intervals of increasing and decreasing. So we have the function f of x equals x cubed plus x squared minus 4x plus 1. So when I graph it in Desmos, this is what the function is going to look like. And it has 2 turning points. We have a point up here and a point down here. So if we look at the start of the graph, it starts increasing, then we decrease, then we increase again. So we're going to have multiple intervals of increasing. So let's start with our increasing intervals. So it starts out increasing, so it increases from -infinity to our first turning point, which occurs at negative 1.54. Then we have a second interval, so union, and our second interval starts at our second turning point, which starts at 0.87 and goes and continues increasing after there, so to infinity. Our decreasing interval occurs between those two turning points. So it's from negative 1.54, between negative 1.54 and 0.87. And then if I wanted, we could label those turning points as maxes or min, since we know how to do that. So this first turning point here is going to be a local max. And our second turning point here at the bottom is going to be a local min. So when you're determining intervals of increasing or decreasing, you always identify any turning points. That's what these top and bottom curves are called. They're called turning points, and figure out the x values for which between your increasing and decreasing. We're always looking at x values for increasing and decreasing. And we're talking about local max or local min. We're looking for those turning points, or those high points and those low points, and we're just writing the coordinates for those.